Hello, I'm Krishna Mohan, register number 392. Today we are going to present privacy preserving query processing using fully homomorphic encryption. So today most organizations use cloud databases to store and analyze their data, but that comes with a major privacy risk. Once data is sent to the cloud, it's often exposed during processing. Traditional encryption protects data only while storing or transmitting it, but not while computing. That's where fully homomorphic encryption or FHE comes in. FHE allows computations to be performed directly on the encrypted data, which means even an unstructured cloud server can process queries without ever seeing the actual data. In our project, we implemented a prototype that uses Python and 10C library to perform SQL queries on encrypted data. And the compared
Excellent.
results with normal unencrypted data were the same. Next, my teammate Lokesh will continue.
Excellent. Architecture diagram. Yeah, my name is Lokesh and my registration number is 384 from C2 section. So I'm explaining about the architecture diagram of this project, of this dev report topic, fully homomorphic encryption. So here we got a live example of hospital management. So there are some phases of this hospital management. First layer of this patient layer and encryption phase and decryption phase after requests in between, and then the end results will show the fully explaining examples as if the patient has a client, and their data will be stored in the cloud as security purpose of passkeys will be related, and then later on the request is sent to the cloud service. So then the encryption format will be transferred and decrypted, and then ends to the results. So by this, the diagram how it works, as you can see in the architecture diagram. So next on, my friend will continue. Jervin.
I'm Jevin Anto from 377. I'm going to talk about the case study on healthcare applications. A hospital analyzes encrypted patient data to detect disease trends and security. Patients' data or age, diagnosis, and medication is encrypted before the cloud upload. The cloud performs the analytic like average age for condition X directly on the ciphertext. Results remains encrypted until the decrypted by the hospital, protects sensitive patient data even during the computation, enables multiple hospital collaboration while ensuring the compliance with the HIPAA and the GDPR, proves that privacy and analytics can coexist effectively. Next, my teammate will continue.
Uh, my name is Meghnad. I'm register number is 422. So inference of our case study is that encrypted query results match plain text queries with 0.1% accuracy. FHE introduced 100 to 165x latency overhead, expected but consistent. Ciphertext storage was 11 times larger, but batching reduced it to 2 to 3 times. Query performance scaled linearly except for joins which remain costly. FHE databases are ideal for batch analytics, not real-time OLTP systems. Optimization and hardware acceleration can significantly improve practicality. Demonstrates that privacy-preserving analytics are achievable with current tools. So, conclusion.
To conclude, our study shows that it is definitely possible to run database queries securely on encrypted data using FHE. So the results were highly accurate, almost identical to the unencrypted queries. Anyway, the performance overhead was roughly around 100 to 165 times. However, this is predictable trade-off for the strong privacy and confidentiality that FHE offers. With furthermore optimization and hardware acceleration, this approach could soon become practical for real-world use, especially in healthcare, finance, and government sectors. So that's all. Thank you.